Today we are going to talk about graphing ellipses. By the end of this video, you should be able to graph an ellipse in standard form, and you should be able to convert the equation of an ellipse from general form to standard form. First, let's take a look at our conic sections. If you slice a cone on an angle, the resulting cross section will be an ellipse. An ellipse is just a fancy name for an oval. If in the equation of an ellipse A equals B, then that gives us a circle. Again, we have two different types of ellipses. First, we have a horizontal ellipse. And the standard form for a horizontal ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. We also have a vertical ellipse. And the equation for a vertical ellipse is almost identical, except that a and b switch places. So we have x minus h squared over b squared plus y minus k squared over a squared equals 1. And in this case, a is always bigger than b for both forms. Some applications of ellipses are orbits of planets and other things in space. You have an elliptical machine. And a whispering chamber. We'll talk about that more in a minute. An ellipse is the set of all points in a plane such that the sum of the distances from the two fixed points, called the foci, is constant. So let's look at a few of the key features of an ellipse. First, we have a center, we have two focuses, and the plural of focus is foci. Then at each end, we have a vertex. And note that both of the vertices and the foci and the center will all be in a straight line. And that straight line here is called the major axis. Then we have two co-vertices. And the co-vertices and the center are all in a straight line, and that line is called the minor axis. As mentioned earlier, standard form for a horizontal ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. And we are always going to have a greater than b. So in this formula, the center is going to be hk, the vertices are a away from the center, So this distance is A. The co-vertices are B from the center. So this distance is B. The foci are C from the center. So this distance here is C. And we are going to define C as the square root of A squared minus B squared. So if the distance from the center to the vertex is A, then the distance between the two vertices, which would be the major axis, is going to be 2A. Also, since the distance from the center to the co-vertex is B, that means that the distance between the two co-vertices, which is the minor axis, is 2B. So let's look at an example. First, we need to decide if this is a horizontal or a vertical ellipse. And the way you can figure that out is by looking to see whether the denominator of the x fraction or the denominator of the y fraction is larger. So in this case, the denominator of the x fraction is larger, which means that this will be a horizontal ellipse. So our center is at HK, which is 2, -3. Then we need to figure out what A and B are. Our vertices are A away from the center. A is going to be the square root of 25. So A is 5. So we're going to go 5 units in the x direction from the center to find the vertices. So that'll be -3, -3, and 7, -3. The co-vertices are B units from the center. So to find B, we need to take the square root of 9. So B is 3. So we need to go 3 units in the y direction. So that would make our co-vertices the points 2, 0, and 2, -6. Then to find our foci, we need to find the value of C. So we mentioned on the last slide that C is going to be the square root of A squared minus B squared. So C will be the square root of 16, which is 4. So this means that our foci are 4 units from the center. So those points are -2, -3, and 6, -3. Then the length of our major axis is 2A, which will be 10. The length of our minor axis is 2B, which will be 6. Then we can connect our vertices and co-vertices to form our ellipse. And there we go. For a vertical ellipse, everything is very similar to that of the horizontal ellipse. Our equation is x minus h squared over b squared plus y minus k squared over a squared equals 1. And we still have that a is greater than b. So we still have the center at HK. We still have that the vertices, which are now at the top and bottom of the ellipse, are still A units from the center. The co-vertices, which are now on the left and right sides of the ellipse, are still B units from the center. Foci are still C units from the vertex. And C is still the square root of A squared minus B squared. So if we look at problem number 2, we know that this is a vertical ellipse because the denominator of the y fraction is larger than the denominator of the x fraction. So our center is still HK, which would be -1, 3. Then we need to find out what A is to figure out our vertices. So we look for the larger denominator, which is 49, and take the square root of that to get A. So A is 7. And since it is the denominator of the y fraction, we're going to go 7 units in the y direction to find our vertices. So those points are -1, 10, and -1, -4. Then we need to know what B is to find our co-vertices. So B will be the square root of 25, which is 5. And then we are going to go 5 units in the x direction to find our co-vertices. So our co-vertices are going to be -6, 3, and 4, 3. Then to find our foci, we need to find the value of C. So C is going to be the square root of 49 minus 25, which gives us square root of 24, which is 2 square root of 6. But that doesn't help us graph this, so we need to use our decimal approximation. So 2 square root of 6 is approximately 4.9. So we are going to go approximately 4.9 units to find our foci. So starting from the center, that would be about there. And there. So our foci are -1, 7.9, and -1, -1.9. Then our major axis is going to be 2A, which is 14, and our minor axis is going to be 2B, which is 10. Then we just connect the vertices and the co-vertices to draw our ellipse. Lastly, let's look at converting an ellipse from general form to standard form. So here we are going to have to complete the square. Let's start by grouping our x and y terms together. And I'm going to go ahead and move the constant to the other side of the equation. Now, before we can complete the square, if there is a GCF, we need to factor it out. So for the x terms, I need to factor out a 4. For the y terms, there is no common factor to pull out. then I can go ahead and complete the square. For the x's, if I do b divided by 2 squared, I get 1. And for the y's, if I do b divided by 2 squared, I get 9. Before you add to the other side, you need to be careful. For the x's, there is a GCF out in front, so we need to make sure that we multiply 4 times 1, so we'll actually be adding 4 to the right side of the equation. For the y's, there was no common factor, so we can just add 9. Then we need to factor. And since we need it to equal 1, we need to divide everything by 4. This will give us a final equation of x minus 1 squared over 1, because we divide by 4, so we have 4 divided by 4, simplifies to 1, plus y plus 3 squared over 4, because we're dividing by 4, equals 1. So now we need to figure out if this is a vertical or a horizontal ellipse. So we look at the denominators. The larger denominators occurs with the y. So that means that the larger dimension is going to be the y dimension, meaning that this is a vertical ellipse. Our center is still HK, 1, -3. To find our vertices, we need to figure out what A is. So A will be the square root of 4, which is 2. So since that is the denominator of the y fraction, we need to go 2 units in the y direction to find our vertices. So our vertices are 1, -1, and 1, -5. To find our covertices, we need b, which will be the square root of 1, which is 1. So we're going to go 1 unit left and right to find our covertices. So that'll be 0, -3, and 2, -3. The foci are c units from the center. So c is going to be the square root of 4 minus 1, which is square root of 3. Square root of 3 is approximately 1.7. So our foci will be approximately 1.7 from the center. So that's 1, -1.3, and 1, -4.7. Then our major axis is 2a, which is 4, and our minor axis is 2b, which is 2. Then we can just go ahead and graph our ellipse.